So the topics that I am going to discuss is number 1, assigning realistic durations. Number 2, computer applications. Number 3, schedule coding system. And number 4, cost distribution. Assigning realistic durations. The durations that are assigned to activities are important because the critical path, timing of activities, distribution of costs, and utilization of resources are all a function of activity durations. So, a little throwback about the CPM network diagram. It defines the activities or sequencing of activities by using network diagram to visually represent the tasks sequences of a project. However, kailangan nato i-determine ang anticipated time or expected time na required to complete each activity and in order to schedule the entire project. So the assignment of the duration that is required to accomplish an activity will vary depending on many factors. Quantity and quality of work. The next is number of people and or equipment that is assigned to the activity. So, for example, tama lang imong equipment, then ang number of people ninyo is kulang. So, dili jud ninyo na ma-accomplish dayon ang time duration na naa sa schedule kay mas slower man na inyong work ana kumpara sa kung tama lang inyong number of people and tama lang pod ang inyong equipment. So, next is level of worker skills. So, isa pod sa mga factors ang level of worker skills. Kay what if naganid mo og mga tao na may skills sa masonry, then alangan mag-hire mo og mga tao na walay skills ana nga field. Next is availability of equipment and work environment. So what if nag-schedule na mo og time sa inyong project, then kulang-kulang daw yung equipment. So samot mo ma-delay ana, then dili pa jud mo comfortable sa inyong work environment. Magsige lang mo times na magsige lang og ang mga workers magchismis like ana. So next is effectiveness of supervision of the work. So kailangan pod nato i-supervise ang mga tao or ang atong work kay wala ta kabalo bisig natay mabuhat na mali or na sila nabuhat na mali or sometimes nagachismis lang sila, ikaw lang ginabantayan, so makompromise ang trabahoan na makompromise ang ang project. Although these variations exist, a special effort must be made to determine a realistic duration for each activity because the duration that is assigned to activities in a CPM network diagram has a large impact on the schedule and overall management of a project. Really, the duration of an activity can be determined by one of 3 methods. First is by analyzing historical records from previously completed projects. So, ma-determine do na to ang duration sa isa ka activity or project by analyzing historical records from previously completed projects. Like, kay gusto mo gusto niyo mabalaan kung pila ang time duration or pila ang time duration sa pag-build sa like kunwari sa building sa Unitap. Then kung i-analyze nimo ang ilahang records or schedule sa ilahang project tong pag-construct, then nakabutang na dito sa ilang schedule kung pila ka adlaw or pila ka months na nila gi-construct ang building. Second is by referencing commercially available manuals that provide costs and production rates for various types of work. So second daw is kuha ka og reference sa mga manuals na naga-provide og costs and production rates para sa various types of work. From the experience and judgment of the person who will be performing the work. Like, sa mga engineers na or mga senior engineers nga nanay experience sa construction or na mga project na nadaghan. So pwede ta mag-base sa ilang mga works para ma-determine nato ang duration sa ato ang project. And it is often desirable to determine the probable duration by several methods so the results can be compared to detect any significant variations that may occur. An example, the following illustrates the evaluation of overlapping tasks of the work package to determine the duration of an activity on the CPM diagram. Tasks of work package, project engineering, they have 5 days duration, structural design 16 days, CAD operator 9 days, then the total design days is 30 days. Next topic is computer applications. The construction industry's information environment is undergoing rapid changes. The construction professionals now expect fast and reliable access to rich data sources. Significant advances have been made in streamlining the creation and dissemination of computer-aided design, drawings, and construction documents through incorporation of information technology in the workflow. However, there is a need to go beyond just the automation of existing paper flows and provide the construction knowledge worker with tools that can be easily used to document previous project experience, track new technological developments, and then incorporate this in the formulation of construction strategies for future projects. Atong panahon karon no, more on modern technologies naman jud ta, so gi-adapt pod sa ato ang field ang mga modern technologies like computer applications para mas mabadali o mas detailed and organized ang ato ang mga informations or schedule sa atong project. Work diagram by itself identifies the sequencing of activities but does not provide the scheduled start and finish dates, the distribution of costs, or the allocation of resources. This information can easily be determined by assigning the duration, cost, and resources that are required of each activity. There are many CPM computer programs available to perform the numerous calculations necessary to determine the scheduled time, cost, and resources of activities. Although the number, type, and format of the computer-generated output reports vary widely, depending on the software. The basic input data required for each is the same information. The information required for the input data consists of activity number, description, duration, cost, and resources, such as labor hours. The sequencing or interrelationship of activities is defined by the CPM network diagram. The input data are the same information that is compiled during preparation of the design work packages for the WBS or during preparation of the estimate for a project by the construction contractor. Thus, the computer application of CPM is appropriate for both the design and construction phase of a project. The third topic, the schedule coding system. A coding system allows you to standardize definitions and categories of items and activities between projects and among project stakeholders. The coding system provides numerous options for selection of activities by the project manager. For example, all Solar Line activities can be stored from the complete list of project activities by selecting those activities that have a 1 in the first digit. A coding system provides a means of obtaining many other reports. For example, a sort of all activities related to trenching and laying pipe can be obtained by selecting activities that have a second code digit number that is greater than 2 and less than 5. So, reference table 4. So, mao ni siya no. Line activities is makita sa code digit number 1, which is karing naa diri sa pinakauna. Then, ang activities related to trenching and laying pipe is sa code digit number 2, karing naa diri sa ikaduha, which is cost distribution. The distribution of costs with respect to time must be known to successfully manage a project. In the preceding sections, the scheduled early and late starts and finishes were calculated based on the duration and sequencing of activities. A cost analysis can also be performed by assigning the cost that is anticipated to complete each activity. The cost of an activity may be distributed over the duration of the activity. However, the activity may be performed over a range of time, starting from the early to late start and ending from the early to late finish. Because of activities can occur over a range of time, a cost analysis must be performed based on activities starting on an early start, late start, and target schedule. The target schedule is the midpoint between the early start and the late start. Table 8 to 5 illustrates the early start cost analysis calculations for the sewer and water lines project, shown in figure 8 to 5. For each day in the project, the cost per day of activity that is in progress is summed to obtain the total cost of the project for that day. So, money siya ang table 8 to 5. Cumulative project costs are divided by the total project cost of $147,500 to obtain the percentage cost for each day, which is kani siya. The percentage time for each day is calculated by dividing the number of the working days by the total project duration of 94 days. Similar calculations can be performed for activities starting on a late start schedule and target schedule. Although the calculations for a cost analysis are simple, many are required, as illustrated by the small sewer and water lines project that has only 25 activities and a 94-day project duration. A small microcomputer can perform all the calculations for cost analysis of a project with several hundred activities in less than 2 seconds. Figure 8 to 10 is a computer printout of the daily distribution of costs for the calculations illustrated in Table 8 to 5. A similar analysis can be performed for other resources, such as labor and equipment. For example, a daily distribution of labor hours, similar to Figure 8 to 10, can be used to detect periods of time when the need for labor is high or low. The project manager and his or her team can detect this problem early and appropriately adjust the project plan or acquire additional personnel if needed and available. The cumulative cost graph for a project is commonly called the S-curve because it resembles the shape of the letter S. The early, late, and target cumulative distribution of costs can be superimposed onto one graph to form the envelope of time over which costs may be distributed for the project. This graph links two of the basic elements of a project, time and cost. Accomplished work must also be linked to time and cost. So, mao ni siya ang figure 8 to 12, which is ang S-curve. Detailed og explain ang S-curve kay matakel siya sa chapter 9. So, that's all. Thank you.